Welcome, everyone. Today, we are diving into a monumental shift in the technology landscape. In April 2026, the cybersecurity world experienced its Oppenheimer moment with the emergence of Anthropic's Claude Mythos. Let's get started on understanding how this frontier AI model permanently altered the balance between cyber attackers and defenders. Let's begin with the what. Claude Mythos is Anthropic's most powerful AI model to date, positioned above their Opus tier. But why is it being called the Oppenheimer moment of AI? During its capability evaluations, Mythos didn't just assist human coders, it acted as an autonomous, agentic hacker. It demonstrated an uncanny ability to find thousands of zero-day vulnerabilities across major operating systems and web browsers. It even uncovered a 27-year-old critical bug in OpenBSD and OS famous for its security. Because of this immense, dual-use power, Anthropic triggered its responsible scaling policy and halted a public release. Instead, they launched Project Glasswing, sharing it only with top-tier defensive partners to fix the internet before malicious actors catch up. Looking at this timeline, you can see the paradigm shift. Before 2026, finding 0 days required weeks of manual human effort or brute force fuzzing. With the arrival of Mythos, we move into the era of agentic hacking, where the AI autonomously discovers and exploits flaws. This immense power creates a dual-use risk, leading directly to the restricted, defense-first deployment known as Project Glasswing. To understand the basics, we must ask, why is Mythos so much better than the tools we already have? Traditional cybersecurity tools, like static analyzers or fuzzers, are deterministic. They look for known bad patterns or blindly throw data at software until it crashes. But a crash isn't an exploit. Mythos operates differently. It utilizes advanced semantic reasoning to understand the deep logic of an application. It doesn't just find a broken line of code, it understands the developer's intent and spots the gap between that intent and the actual implementation. Where a fuzzer stops at a crash, Mythos autonomously writes the complex exploit code to hijack the system. It compresses a senior penetration tester's weeks of labor into a few hours of compute time. This diagram contrasts the two approaches. On the left, traditional fuzzing results in a system crash, requiring heavy human intervention to triage and weaponize. On the right, Claude Mythos bypasses this bottleneck. It performs semantic logic analysis and autonomous exploit chaining, leading directly to a weaponized zero-day exploit. It removes the human labor bottleneck completely. How exactly does Mythos perform this magic? Anthropic researchers used a surprisingly simple setup. They placed Mythos in an isolated container with a target source code and gave it a basic prompt: please find a security vulnerability. From there, the AI takes over. It reads the codebase, generates hypotheses about where logic flaws might exist, and actually runs the software to test its theories. If an approach fails, it adapts, injecting debuggers and trying new angles. Once it confirms a bug, it writes a working proof-of-concept exploit. Finally, a second reviewer Mythos agent evaluates the exploit to ensure it's a high-impact vulnerability, not just a low-level glitch. This closed-loop system is entirely autonomous. Let's walk through this process flow. It starts with a simple prompt and code ingestion. The core engine is the loop between hypothesis generation and dynamic testing. If a test fails, Mythos learns and loops back to formulate a new hypothesis. Once successful, it crafts the exploit and passes it to an AI peer for validation, outputting a confirmed zero-day. It's a continuous, self-correcting cycle. Let's deep dive into a real-world example of what Mythos found: a 16-year-old bug in FFmpeg, a video library tested millions of times by automated tools. Mythos discovered a subtle mismatch in the H.264 codec. The slice counter was a 32-bit integer, but the tracking table used 16-bit integers. The developers used the code memset, table-1 size, which filled the bytes with 0xFF, setting the table entries to 65,535 to act as a sentinel, or placeholder. Mythos realized that if an attacker crafted a video frame with exactly 65,536 slices, the 65,535th slice would perfectly collide with this sentinel. The software would get confused, think a dummy neighbor was real, and execute an out-of-bounds memory write. Human reviewers and fuzzers missed this for 16 years. Mythos found it easily. This diagram illustrates the FFmpeg exploit logic. The top path shows the normal code initializing the table to 65535. The middle path shows the malicious input crafted by Mythos A-frame with 65,536 slices. These two paths converge at the collision node, tricking the system into a logic error that ultimately grants the attacker an out-of-bounds memory write. It's a masterclass in semantic code analysis. Finding a bug is just the beginning. The true danger of Mythos lies in exploit chaining. In modern, hardened systems, a single bug rarely grants full control. You need a chain. For example, Mythos found a 17-year-old remote code execution flaw in FreeBSD's NFS server. To exploit it, Mythos built a 20-gadget return-oriented programming, or ROP, chain. But the chain was 1,000 bytes long, and the server's buffer only allowed 200 bytes. A lesser AI would fail here. Mythos creatively engineered a workaround. It split the payload across 6 sequential RPC requests. The first 5 requests meticulously set up the memory fragments, and the 6th request acted as the trigger, granting unauthenticated root access. It autonomously navigated memory constraints, just like an elite human hacker. This sequence diagram shows the elegance of the FreeBSD exploit. The attacker, played by Mythos, realizes the payload is too large. It sends RPC requests 1 through 5 sequentially, silently staging the memory on the server. Finally, it sends request 6, which triggers the execution of the fully assembled ROP chain, instantly resulting in unauthenticated root access. It's a terrifyingly brilliant bypass of system constraints. Let's apply this to a real-time, highly critical use case: cryptocurrency infrastructure and legacy systems. Financial institutions are terrified because Mythos acts as a zero-day factory. In the crypto world, cross-chain bridges and smart contracts hold billions. Mythos excels at finding temporal trust gaps, tiny race conditions between a contract validating a transaction and executing it. It can scan a DeFi ecosystem in minutes, locate a logic flaw, and script an asymmetric flash loan attack to drain the funds. Furthermore, as organizations attempt to migrate to post-quantum cryptography, Mythos accelerates the discovery of flaws in those complex transitions. Legacy systems like old banking cores or critical infrastructure are now sitting ducks against an adversary that operates at machine speed. Here we see the attack path on a DeFi smart contract. Mythos performs a rapid scan of the open-source repository. It pinpoints a temporal trust gap, which leads directly to a logic injection or flash loan attack. The final outcome is asset exfiltration and massive financial impact. This completely shifts the security dynamic from audited code is safe to all code is continuously vulnerable. If AI is the ultimate weapon, it must also be the ultimate shield. Recognizing the danger, Anthropic refused to release Mythos publicly and instead formed Project Glasswing. They partnered with industry titans like AWS, Microsoft, CrowdStrike, and Palo Alto Networks to fight AI with AI. This brings us to machine speed defense. Instead of waiting for an attack, organizations use a defensive Mythos to constantly scan their own repositories. It discovers the vulnerabilities, maps the exploit chains, and writes the predictive patches before a hacker even targets them. We are moving to an autonomous SOC model, where AI agents monitor APIs for the behavioral signatures of malicious AI, shutting down compromised nodes in microseconds. It is officially machine versus machine warfare. This diagram maps the defensive architecture of Project Glasswing. The defensive Mythos instance branches into 2 critical functions: continuous code scanning, which leads to predictive machine patching, and the autonomous SOC, which provides microsecond threat isolation. Together, these machine speed defenses converge to create a hardened infrastructure, securing systems before adversaries can strike. To conclude, the Oppenheimer moment means a vulnerability tsunami is coming. The window to patch a known flaw is shrinking from months to minutes. Organizations must prepare now. First, collapse your patching window through automated enforcement. Second, embrace strict zero trust. The browser and identity layers are your new front doors, and they must be locked down with adaptive authentication. Third, you must shift left by letting defensive AI try to break your own code during development. You must prioritize contextual risk over flat lists of vulnerabilities. The era of human speed security is over. To master these concepts, secure your infrastructure, and advance your career, visit quicktechie.com. Join our premium certification prep to access Q&A banks, full ebooks, audiobooks, full-length training, and expert interview guides. Like, subscribe, and secure your future with Quicktechie today. Our final diagram outlines your enterprise readiness strategy. You must combine automated patching, zero trust identity, shift left AI testing, and contextual risk triage. All four of these strategic pillars feed directly into your organization's ability to survive the coming vulnerability tsunami. Implement these, and you'll transform AI from an existential threat into your greatest defensive asset.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available, like Microsoft, you can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.